morning, and thanks for the introduction. So today what we're going to talk about is gestures in JavaScript. Just to say a little bit more about myself before I get into the topic and like why maybe I'm talking about this. My name is Gerard. I'm a developer advocate at Stripe. If you've never heard of Stripe before, or if you've never used it, we're a fintech company, and we provide a lot of different services and products from I have to remember. Oh, that's my job. Either like fraud detection or online identity verification. But I think we're probably most well known for products around having like checkout experience, so that we handle the difficult parts of payment, so you don't have to. But as a developer advocate, I work on a variety of different things. If you know what the advocate role is about, everybody will kind of give you a different definition. But we have a lot of open source samples, so a part of my job is to keep that up to date. If you've used Stripe before, you might have noticed that we provide different samples in like 7 different programming languages, so that's a lot of maintenance. And I create educational resources around helping people understand how to use our products. But maybe the most interesting part of my job, at least for me, is to do more general technological research. So even though Stripe is a fintech company, we're interested in technology in general and where innovation can lead us, and how the amount of things that we can do with technology. So I'm lucky enough to be able to sometimes pick a topic that I'm interested in learning more about, and I ask myself can I do X with Y? And then I can spend my time researching this, and if it is, if it has an application with Stripe, then good, but if not, that's fine too, which is great. As long as I share what I learn, this is what is really important. But apart from that, I'm a Google developer expert in web technologies. I'm the author of a book about TensorFlow.js. And overall, I kind of prefer to call myself a creative technologist, because what I really love is exploring how far we can push the web and technology in general. And hopefully, in this talk, I will show you a little bit about the type of stuff that I'm into. But to get started, I want to talk about human-computer interaction. So it's usually shortened as HCI, and it's a subfield of technology that is focused on the interaction between computers and humans in terms of inputs and outputs. So if you think about when you're using a mouse, the input would be dragging or clicking the mouse, and the output is the cursor moving on the screen. If you think about a keyboard, it's a different kind of input, because all of a sudden you're pressing keys, and the output is also different. It's usually letters if you're writing a document, or directions in a game if you're using the arrows. But there's also touch screens that are different kind of input. There's voice interactions, there's joysticks, and things like that. So it's something that, as developers, most of the time, or at least JavaScript or front-end developers, we don't really hack on that very often. Most of the time, we rely on standards that other people have put in place, and we use them through web APIs. So we didn't define that a mouse has to be like drag or clicked, but we use these interactions through on-click events or on mouse down, to scroll animations and things like that. But it's not because we don't define these standards that we can't explore that space and experiment with other ways to interact with interfaces and explore different interactions. So if you spend some time thinking and imagining that the mouse and the keyboard don't exist, how would you want to interact with interfaces? How would you want to browse data? And an example of potentially innovative interactions is with motion detection. So if I ask you to think about just motion detection in general, or in your day-to-day, you might think of something like this. I guess the first thought that comes into your mind might be a standard motion detector. It turns lights on or off in an office or outside your house. Some of you might have one, or even a security alarm system, but that's kind of pretty much it. What it detects is there movement or not? It doesn't particularly detect specific movements. For example, it doesn't know if you're walking or running or jumping. When you enter an office, it doesn't know that you've opened the door or that you're running into a room. It just knows that there's movement compared to a state before and a state now. It doesn't even know if the movement was created by a person, an object, or an animal. And if you want to build something pretty standard like this as a JavaScript developer, you can. So the talk before was talking about Arduinos, so I'm not going to go too much into this. You might have, if you were here, you probably know what an Arduino is now, or even a Raspberry Pi. And you can use a motion sensor, like a small radar or a PIR sensor, and you can get live data from that and customize your application using JavaScript. But these two sensors, so either a small radar or a PIR sensor, they're just as standards as the one that you can buy in store, meaning that they can detect that there's movement, but it doesn't really know anything more than that. However, movement is actually more complex and interesting than is it just a state or like on or off. You can have a lot of contextual information that's associated with a movement. And for example, even if we just take the time of day and the location. So let's imagine that you're wearing a sensor on your leg and it tracks your activity throughout the day, the same way that some people track their sleeping pattern or their heart rate or things like that. And if you're used to exercising at the gym, so location is gym and the time is the evening, then you can kind of create patterns about your activities throughout the day, and your legs are doing the, the running movement. But then if all of a sudden the system tracks that you are running in the morning and outside, all of a sudden the time of the day and the location is different, but the movement is the same. And these activities actually mean different things, because if my usual pattern of activity is gym at night, all of a sudden if it's the morning and outside, I might be actually doing like running after a bus, for example. So even though the movement is the same, the context in which it is done is then, it does then mean different things. But even then, a similar movement could mean different things. So if I'm waving my hand to say hi to somebody at a conference from afar, even though the movement is wave, it's different than if I wave to catch a bus or a taxi. Like, even though the name of the movement is the same, I'm like waving, I actually do it in a much different way that means something different. So there is some kind of information necessary to understand what is going on. Even if I do a thumbs up, you kind of all know what that means, like, oh yeah, it's okay, and then a wave is different. So can we take advantage of the fact that movements are actually quite contextual and specific to build systems that are more interesting than the only on or off motion detection? So well, the answer is yes, and this is what I'm going to dive a little bit more into in this talk. So it is possible, and even better, you don't have to put that much effort into it to actually make this happen. So the first step is to use a microcontroller with a built-in accelerometer and gyroscope. So the one that I'm using for my experiments at the moment is an Arduino 33 Nano BLE Sense. So that's a long name for an Arduino, but if you have been tinkering with Arduino, you might know that there's a lot of different models. So if you want to replicate what I'm going to show you in this talk, it's going to be easier if you use the board that I'm using. There's a similar model called the Arduino Nano 33 IoT Sense, but you wouldn't want to do that one. You wouldn't want to use that one if you're doing this kind of experiment, because we need connection to the browser via Bluetooth, and the IoT one uses Wi-Fi. So this board is super small. I have it here. If I don't know if you can see on the video, it's like the size of a thumb. It's not too expensive. It's about $40 US. And at the moment, it's a bit sold out in a lot of different places. So if you want to get one, you might have to wait a little bit. But there's really cool boards. There's not only an accelerometer and gyroscope on it. There's also a microphone and a color sensor and a lot of different things. But I'm just going to focus on the gyroscope and accelerometer. And the reason why you do need these sensors is because you get 3 points of data for how your body rotates, so the X, Y, and Z coordinates for the gyroscope, so how your body rotates, and 3 points of data for the accelerometer, so how fast you move. So X and Y coordinates for both of these attributes multiple times per second, it actually gives you quite a lot of data to differentiate multiple movements. OK, so that's for the hardware part. But how do we actually do something with it? So for the software part, we are going to use machine learning with TensorFlow.js and a bit of Arduino. So again, if you've never tinkered with Arduino, you mostly need to upload a pre-written sketch that is open source. So you don't have to write any C code if you don't want to. And why is machine learning involved? Because the board is going to gather live data about movements and to predict the gesture that we execute based on some training data that I'm going to record. So by default, when you first plug an Arduino into a computer, it's not ready to handle any machine learning model. It doesn't have that built-in logic. So to make it work, we upload a pre-written sketch. A sketch is just the name of a program in Arduino. And it's open source, and it adds the logic to connect to the browser via Bluetooth, and then able to receive the machine learning model from the browser and run it with live data. So the sketch is open source. You can find it on GitHub, and you can upload it to the board either via the Arduino app that you can download on your laptop, or now there's also the Arduino Web IDE. So if you don't want to upload anything, or if you don't want to download any software, you can use the same files and upload them through the board via the UI. So, so that's for the Arduino part. But for the part that you can do in JavaScript, there's a lot of different steps that you can do on your own. So if you want, you can start by handling the connection to the Arduino. Then you can collect the live data. Then you can process it. And by processing it, I mean that when you receive live data from the Arduino, you get like an array of integers. And that's not really the data type that TensorFlow can work with. So there's a lot of processing, like attaching a label to the data and then transforming it to tensors and then giving it to a machine learning model. So you kind of have to prepare your data. Then you can create the machine learning model using TensorFlow.js. Then you can train it. Then you can test it, then you can export it, and then after that you can use it. So you can do all of these steps on your own if you want from scratch in JavaScript. But the point of my talk today is to show you a tool that can do that in a few minutes and via a UI. So it's called Tiny Motion Trainer. It's a tool that is built by Google Creative Labs. And it allows you to do all of the 7 steps that I showed you on the previous slide, but in a few minutes through with a few clicks. So I'm going to try to show you quickly how it works. OK, so I'm going to plug my Arduino, and I should be moving. Oops, well, that's the slide after. All right, so that's Tiny Motion Trainer. And the first, I'm just going to say that I want to start a new project. And the first step is to connect to the Arduino. So when you use the Web Bluetooth API, the first thing that you need to do is usually a user action. So usually it's a click. And what that means is that you want to make sure that the user intentionally wants to connect to the Arduino. For security reasons, you don't want your browser to connect to whatever nearby device automatically. So we use a user gesture, which is, most of the time I use a click as well. So if I click that and I say, yes, that's the device that I want to connect to, and I'm going to pair. And if it's pairing correctly, yes, I should have the first setting that's moving as I'm moving my hand. So I will go through what these settings are a bit later. But for now, just to show you the UI, I'm going to move on to the first step, which is capturing the data. So when you play with machine learning, your data has to, depending on what you do with machine learning, but here we're going to add a label. So for my gesture, I'm going to call it wave. And here I'm selecting the wave, and I'm going to start. So I'm going to hold the Arduino. I'm going to hold it like this. And I'm going to start to wave. And I'm just doing my gesture, and it's just recording live data and visualizing it. I'm going to stop at like 15 samples, or 16, whatever. So it's a bit like random, the amount of samples that you decide to create. You can decide that when you check the accuracy of your model. If it's not very accurate, you can retrain these steps. But so my first gesture is a wave. And then the second gesture, so usually I'd never really know how to call it. I'm just going to call it bling, because it's just like, like money thing. So I don't think that gesture has a name. I was told it was just make it rain, but that's too long to write. So I'm just going to call bling. So I select my second gesture, and I start recording, and I'm just doing it. So I shouldn't have done it that way because, OK, all right. So I'm doing bling, 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 yeah, money. All right, so I recorded a lot more samples for that one, so I'm going to see if it works, actually. But what's interesting, though, is on the right, you have a visualization of the live data coming from the Arduino. And that's kind of like the visual representation of your gesture. And hopefully, depending on the gestures that you record, you should see a pretty significant difference between this visualization. And I can tell you, OK, I think my model is going to be able to find patterns in this data pretty easily. If the gestures were very similar, I might have to record more samples so to give it a chance to find patterns in it. So here we can see that maybe my first one I wasn't doing it properly, so it's kind of similar. But then hopefully we'll be able to find a difference in there. So then you can move on to training your model. And the only thing you need to do is click Start Training, and then not close your browser. But it's going to train a machine learning model live in the browser using the data that we just recorded. So usually it should take a few seconds. It's taking a bit more than usual, probably because I recorded more samples, or maybe the Wi-Fi, I don't know. But usually it takes a few seconds as well. So you can create more gestures if you want. It's going to take a bit longer if we add 3, 4 gestures. But you get a graph of the accuracy and the loss that kind of gives you an idea of how good, hopefully, the prediction is going to be. So it should be done soon-ish. Yeah. OK. I think we're done now. And then you can move on to testing your model. And what it's going to have here is that it has your two gestures. It might be a little bit small, but if you try the UI later, hopefully you'll see better. And if I do my wave, OK, it's pretty good. And if I do my bling bling, yay. All right, and you can just do that like a few times to make sure that it's all right. And later, if you want, you can change the settings to make sure that it detects faster or slower. But anyway, I'm going to, I just refreshed because I'm going to move back to my slides. OK, so this tool is open source as well. So if you want to dive a little bit deeper into how it is created in the background and the type of machine learning model that they used, you can have a look at that later on. So if you even want to recreate your own platforms, you can fork that and have a look. So just one thing that I wanted to mention, because I came across that a few weeks ago, is if you ever wonder what's in a machine learning model, there's something called neutron.app that allows you to upload a model that either you have created or you found open source online, and it gives you the different layers of what the model is made of. So when you create a machine learning model, you have different algorithms and different amount of layers. And if there's a lot of open source models available out there. And if you upload it to neutron.app, you can have a look at what it's made of, and you can recreate your own if you want. So I thought that was pretty cool. If you come across, I don't know, if I find a model that does cool, I don't know, facial recognition things, for example, I can upload it and have a look and try to remake my own if I want to. But now that we have trained a model, what can we actually, how do we actually use that then in the browser? So here I'm going to rely on a script that's called TF4 Micro Motion Kit. So it's also open source, so you can dive a little bit deeper into it if you want as well. So I'm going to cover the different parts of what it does. But I won't have the time to go into all of it. It's about 1,000 lines of code, and I don't think it would be very fun to go through 1,000 lines of code with you. But to understand better what it does, I spent some time kind of working backwards and recreating my own in about 350 lines. So if, the bare bones of what it can do can be recreated in 350 lines. And what it can do is what it does is it sets up the connection between the Arduino and the browser via Bluetooth, and then it sends the machine learning model from, again, your browser to the Arduino, and then gets the gestures back. So to explain a little bit how it works, let's dive a little bit deeper into it. So if you do want to do something similar, you don't actually have to write the code I'm about to show you, because that's covered in the script that you can just import. But I thought it would be kind of interesting. When I looked into it, I went from that moment of oh my God, how does it work, to then oh yeah, it makes sense. So it's I'm hoping that hopefully you'll find that interesting as well. But if you've never played with Bluetooth before, I want to start by explaining a little bit the system of especially the GATT protocol that is used in the Web Bluetooth API. And it works by setting a set of services and characteristics. So if we take the example of a health service, so if you have a heart monitor or a Fitbit or anything like that that connects via Bluetooth, usually you have different services that you can think of them as main functionalities, and under it you have what is called characteristics. And if for a heart rate sensor, for example, you might have so the main would be the main service, the heart service, and then in characteristic you could have the heart rate, or you could have the battery state, or even the state of the device, is it on or off, and you can kind of subscribe to these characteristics to get data from them. But by default, when you connect the Arduino to your computer, no data is transmitted. So if you have a Fitbit, there's already functionality uploaded in it. But when an Arduino, it's kind of bare. If you don't upload any sketch, by default, there is nothing is happening. So you can write your own, and you can set up your own services and characteristics that then you can subscribe to in JavaScript. So if we look at a little bit of C code, I put really the smallest code sample that I could to explain a little bit how this works. But you define different unique IDs that will then be used to kind of identify these services and characteristics on the JavaScript side. So you start by declaring a main ID, and then you can declare your different characteristics. So one would be the file length characteristic, which would be the length of the machine learning model that you're sending to the Arduino. And then you could have one that's the maximum amount of bytes that you can send to the Arduino, the maximum amount that it can handle, and you can have one for the transfer status, am I transferring, or is it over? Can I start the rest of the logic And as well as defining different unique IDs, you can also set the type of things that you can do with Bluetooth. So you can read a value from this characteristic, or you can write, and maybe most importantly, especially in terms of user interfaces, is the ability to notify. So it means that the Arduino is going to be able to notify the browser of the transfer status of the model. And using this code that's running on the Arduino, the equivalent that we can write in JavaScript using the Web Bluetooth API starts with using navigator.bluetooth.requestDevice. And you can specify different filters if you want to kind of target a specific device that you want to connect to. If you don't specify a filter, you're going to see a list of all nearby devices that you can connect to. So just to make it easier, you can use the UUID that is defined on the Arduino and write it there in a variable to make sure that you connect to the right device. The next step would be to connect to what is called like the GATT server, which is like the protocol that defines services and characteristics. And then you can get the primary service that uses the same UUID that is defined on the Arduino as well. And from inside that service, you can also get the characteristics. So we also have, again, our file length characteristic, then the maximum length of the file, and the transfer status. And here, the way that, as I was showing before, transfer status has like a BLE notify functionality. So it means that there's an ability to have notifications between Arduino and the browser. And this is how you get the notifications in the front end. You call the start notifications method, and then you have an event listener that will trigger another function in JavaScript when the Arduino is sending little pings to the browser. OK, so this little part here handled only the connection between the Arduino and the browser via Bluetooth. But the step 2 is transferring the model, because if you connect to the Arduino, then at the moment, nothing happens. So transferring the model, I'm going to go through a very stripped down version of the code that does that. But the first step is to actually load that file. I'm not going to go into that particular function, because if you're building websites, you've probably used fetch or XML HTTP request before. So it's really getting that file that's in your file folder, so the model, the machine learning model, and getting it and transferring it to an array buffer. But then what we want to get into is called a BLE transfer model function with the model buffer, so the data from the model file, and then the different settings that were in the UI as well. So the next step is going to start telling the Arduino, OK, so I'm going to tell you the number of classes that I trained, so the number of gestures, the number, the data, the threshold. I'm going to go into these settings a little bit later. But at this point, you're writing to these characteristics on the Arduino to let the device know that when it receives the model, it was trained with 2 gestures, and it was trained with certain settings, so that then it will be able to do the prediction properly. If you start to send it settings that were different from what the model was trained for, you'll get an error, and it will do weird stuff. And then we can start. So once we've told the Arduino that certain settings that the model was trained for, we can move on to actually start to transfer the file. And here, we have the maximum, we have different variables. We can read the maximum value that the Arduino can handle. And then we can do some comparison between the length of our file, also our model, and what the Arduino can do. So if you trained maybe too many gestures, or if you have too many samples, and the length of the file is larger than what the Arduino can handle, it will just not transfer it. And here we do something interesting, that we do a checksum. So we start with a checksum from the browser. We send that little value to the Arduino, so that if the checksum characteristic is different from what was sent from the browser to what is received on the Arduino, the file somehow has been corrupted in between, and it's not going to work neither. So it's to make sure that the model that you send from the browser is the same as the one that you receive on the Arduino. You can do a checksum as well. I'm not going to go into how to do the checksum, because I actually don't know how it works. But it looks really interesting. But it's the type of stuff that I definitely want to learn more about. And then we can start sending blocks of data. So here we're calculating the amount of bytes remaining, because we're going to split the model into chunks. You can't send the entire file as it is. So you break the model into chunks, and you send them one by one until the entire thing is done. So you calculate the block length, and you organize your model into block views, and you kind of call this on repeat. So you're writing to the characteristic that will handle, that will receive the block or the model in the Arduino. Then you calculate if you have bytes remaining as you're sending it. And until we've sent the entire file, we're just calling this function over and over until the whole thing is sent. So, and then what we can do, once the Arduino has actually received all of the model, we can start running it and notifying the browser. So the part that runs the model on the Arduino, I'm not going to cover that, but what happens then in the JavaScript is that when I showed you about like starting notifications and having an event listener that will be triggered when the Arduino notifies, you can then call, like for example, this one is a handle inference change that will receive the data from the Arduino, and we can then get values that's in it. For example, the index of the value that was trained, the score, and the velocity. But maybe the one that I would like you to think more about, because again, you shouldn't have to write any of this particular code, but it's like actually implementing gesture control in the browser. Because the parts that I just covered are kind of like a mini deep dive into the script that you can download from GitHub, but the code that you would have to write would be the one that just follows. So here, you would load that script onto your app the same way that you load any other script, either a script tag or an import statement. But this is kind of like in a few, I think I have 2 slides. So in like 50 lines of code, you can actually implement gesture control in the browser. So when you import that script, it adds on the window object a method called tinyml experiment BLE interface. So again, this is like a very long name, but at least you can be sure that it won't conflict with anything that you already have available on the window. And the first thing that you do, or that you have to do, is call the create connect button method. And what that does, you have to have a button on your page. Again, with the Web Bluetooth API, you need an interaction from the user, and usually it's a click. So you use the same ID that you have. So the button has an ID, for example, here connect button container. And you use that ID to kind of reference, OK, when the user is going to click on that button, here's what should be triggered. And then we can start sending the parameters of our model. So the first one is the path to the file. And here, in the last step of Tinymotion Trainer, you're supposed to export the file. I didn't do it because in the demo I want to show you later, I already have the model. But you're indicating the path to the file, and you might notice that the extension of that file is tflite. And it's a specific extension for machine learning models that need to run on low memory devices. So it's perfect for microcontrollers and a lot of other IoT stuff. So the awesome thing about .tflite is that, well, it's light. I guess that's why they called it like that. But my custom model with 2 different gestures is only about 8 kilobytes of data. And comparing to other models that I've used in the past, especially machine learning, or around object detection, for example, they're usually multiple megabytes. So when you create a web experience and you have to fetch a model that's multiple megabytes, you can think about the performance impact that's going to have. But having a full gesture recognition model that is only 8 kilobytes of data, I think that's super impressive. I don't know if you think that's super impressive, but I think it's awesome. Like this whole gesture recognition that's kind of like packaged up in 8 kilobytes of data. That's really cool. So the second one, so these are the settings that you would define in Tinymotion Trainer in the first step. So the number of classes is the number of gestures that you trained. So I trained 2 gestures, so I write the number 2. If you train 3, you write 3. The second one, or the third one here, is the threshold. So it's a value between 0 and 1. And it represents the threshold at which the model will start to classify a certain gesture, so it doesn't try to classify something when I'm slightly moving. So the closer to 0, the more sensitive it's going to be. So if you do want to track very slight movements, you might want it closer to 0. And if you want more intentional gestures, you might want it closer to 1. Then the number of samples represents the number of samples that you recorded in the UI. Then the capture delay is the delay between samples of data used to recognize gestures. So the closer to 0, the faster it's going to look at new live data from the Arduino to predict a gesture, and the closer to 1, the slower it's going to be. So again, depending on what you want to build with it, you might want it to be a lot more responsive than other times. And then you also have a few different events available, such as on connect, if you want to show a message in the UI when the board is actually connected to the browser. You also have on transfer progress, if you want to show a little progress bar as the model is being uploaded. You have an on disconnect if you want to also alert the user, like, hey, the board is not connected, so if it's not working, that's why. But more importantly, you have on inference. And so what this, this function executes when the code on the device has predicted a new gesture in live data, and it notifies the browser. So from the data that we get when on inference is called, we have an index in the data object that represents the index of the gesture trained. So my first gesture was wave, so the index is going to be 0. And my second gesture was like bling, so it's going to be 1. And based on that index, then we can trigger any front-end code that we want. So for example, you can have like a wave and it scrolls down your page, or you can, you can play a video or stop a video or whatever. And I'm only talking about browser things here, but it can really apply to anything that can be controlled with JavaScript. So it's really whatever you can think of. And my favorite part of this is that it abstracts the complexity of building your own gesture recognition system, so you can focus on building your app and experimenting with interactions. So just to recap the steps, because I feel like it was like a lot. So you have to start by uploading the sketch to the Arduino, and I didn't show that part specifically because it really is clicking on a few buttons, like one button, and then it uploads it. So I didn't feel like it was worth it to go into this. But the second one would be so you train your model on Tiny Motion Trainer, and then you export it. And the third step is you import TF4 macro motion kit, and you write some JavaScript. So again, if you want to write your own logic, you could not import tiny TF4 macro motion kit and try to do it on your own. But if you want to experiment and see what it can do for you, you can start that way and then decide if you want to dive a little bit deeper. So I talked a lot about how it works, but I thought I would show you a little bit about the type of things that it can do. And I'm going to start with a project that I built many years ago. I mean, 3-4 years ago, but I feel like such a long time now, that I called Air Street Fighter. And the name indicates that it's Street Fighter in the air. So yeah. So for the first version of this, I shouldn't try to drink and speak at the same time. So the first version of this, I didn't build it using this Arduino Nano 33BLE Sense. I built it with I made 3 different versions, because at core, what it uses is a gyroscope and an accelerometer. So I built it first with another board with separate sensors. So I didn't have a board that had built-in stuff. So I just wired in an Arduino Maker 1000 with an external gyroscope and accelerometer. And I did all of the long steps that I showed you at the beginning, of the 7 steps. I did it all on my own because Tiny Motion Trainer didn't exist. So I went the hard way. And so I can tell you that if you want to do everything on your own, you can, because if I can do it, you can do it too. And I've also built a version with something that I don't even know if it exists anymore. It's called the Daydream controller. Google at some point released a Daydream VR headset that had a controller, and it was Bluetooth connected, and it also had a gyroscope and accelerometer. So I built a little JavaScript library to get the data from that device, and then hooked it up. I think they changed the firmware, and you can't really, it doesn't work anymore. But and the third version that I built was using a phone, because your phone has a gyroscope and accelerometer. You can get live data from the generic sensor API. It worked at the time. I don't know if it still works. But then as soon as Tiny Motion Trainer got released, then in a few minutes, I was able to kind of put all of my logic away and replace it with a few lines. And hopefully, I'm going to try to show you how that works. But it shows you that that type of stuff can actually be built a lot of different ways. So OK, I'm going to move this. OK, and I'm going to change tab. Cool. So one thing that I didn't mention when I showed you Tiny Motion Trainer is that the board is wired to my computer, but it's only for power. It's not at all for data transfer. You could definitely just have an external battery pack and just be able to walk around. It's just I had one. It turns out that I think I was using the wrong voltage, and it was crashing the board. So just for safety, I'm just going to be wired to my computer. But I could be anywhere on stage and try to play that game. So hopefully, it's going to work. So I'm just going to, OK, I'm going to have my click, and then I select my board, and then I pair. And it should be transferring. Yes, OK. So it's transferring data, which is really cool. The first time I used something like this, I was like, oh my God, it's transferring a full machine learning model via Bluetooth, from here to here. Or it could be there to there. But anyway, it's it's super cool that in a few seconds you can have this invisible data stuff being transferred. Anyway, I love this. OK, so I'm going to click Start. And if I have my gestures, if I do like, yes, okay. And if I do this, and okay, the third one, I always fuck it up. So, is it that? No. I know this one. Yes! Woo! Okay. I was like, okay. So, obviously, it's just a prototype, because the second character is not moving. But what I wanted to do was just to validate the hypothesis that that was possible. And coming from the version of it that was really difficult because I did everything on my own, to now being able to, in a few minutes, replace the whole logic with Tiny Motion Trainer and just build a little experiment in JavaScript without being an expert in machine learning is really cool. So that's something that I'm super excited about. So I'm just going to refresh because I have another thing. I'm going to go back there. OK. But maybe games, you're just like, oh, I don't like games. And that's cool. So maybe you're interested in music. And once you start looking into that kind of projects, you realize that there's actually a lot of things that we do with movements that you could just then automate with a piece of hardware. So around the same time that I built Air Street Fighter, I also built something called Air Drums. And again, the first version of this did not use this Arduino. It used devices that I don't know if you can still buy them, but you used to be able to buy them. It's called free drums. And they are devices that connect via Bluetooth, and they have an accelerometer and gyroscope. You attach them to drumsticks, and you can play music. So at the time, the only possible way to play music was to download their software, and I didn't want to do that. I like the web, so I hacked my own little freedrums.js framework, and the result was that. So you could, tap in the air and trigger little animations and sounds. So I didn't convert that one to use Tiny Motion Trainer, but you definitely could. And actually, some people have done that. So there's a project called Air Snare that uses the same concept, but with this Arduino. So if you have it around, you can test it right now. So I'm going to try to show you how it works as well. So this one is not mine. I'm not going to take credit for this. But if I connect it and I select my board, so if you're a real drummer, I know that it doesn't work exactly like real drums, but it's like if you're traveling a lot, or if drums are too expensive, or if you just don't have the space, you can learn to play things even if you on the go kind of thing. All right, so if I do yay. That's it. No, I mean, I can do it more if you want. But it's in this example, there's only 3 sounds. I mean, I probably won't be able to see. Oh, I can see. If I can just change. Oh, cowbell, yeah. All right, so so that's not mine, but you can build that kind of experiments as well. And maybe again, if you're a real drummer, you might think that that's not reactive enough, and you might want to be faster, but you can change settings and make it a lot more reactive if you want to. But you can create your own little musical instruments if you want. And again, so I'm going to go back. So maybe you're not into games, maybe you're not into music, but maybe you're into fitness. And I'm not going to demo that one. You're just going to believe that I can do squats. But the reason why I want to show that one is because all of a sudden, in this example, the board, you're not supposed to hold it in your hand. You can, it shows different places where you can put the board to track movement. This one is on the legs, and you can easily train the system to recognize what a squat is made of in terms of movement data. And then again, you can do whatever you want with it. If you wanted to have a digital detox, you could say you can't unlock your phone until you do 50 squats. Or you get to think about the interaction rather than the complexity of the system. And it made me think about something that I don't know if you play, but I play that. I don't know if I really want to admit it, but Ring Fit Adventure. So I don't know if you play Ring Fit Adventure, but the concept is the same, especially because if you have a Nintendo Switch, the joysticks are connected via Bluetooth, I believe, or if they're not connected via Bluetooth on the game, they definitely are available. You can connect to them via Bluetooth in the browser. And they do use a gyroscope and accelerometer. And it's kind of the same system. So for people who don't play that game, it's like you have this game, and you can run, and you have a device on your leg and a device attached to a ring. And it detects movements, and it tells you different exercises, and you kind of have that instant feedback in the game. If you do the exercise properly, then you move to the next level, or you can beat other characters and stuff. So the concept is exactly the same. It's just that their product looks better than this Arduino. But it means that you could rebuild something similar as well, and it shows that even though what I'm showing you might look like just a side project, you have companies that can actually build real products out of it. But if we go away from movements from humans, we can also have movements from objects around us. And I'm showing that one because, so that was obviously not using the same Arduino, but the concept is the same. And a few months ago, I went to another conference where this couple was giving a talk about how they automated their relationship. So for chores, they built a lot of different IoT systems to kind of like, say like who's going to do what, or have their appliances telling them when they're done doing that stuff. And it made me think that this is something that could be used as well with an Arduino. So instead of buying a lot of separate IoT devices that would, I don't want to replace my washing machine with an IoT washing machine if I can just put that on it, if that's what you're interested in. But, you could think about, oh, well, yeah, the way that a washing machine works, it has different cycles, and even you can hear it in the way that your washing machine runs, that, you know when it's like just starting to wash, or when it's just like, I don't know the name of the cycles of a washing machine, but I just know that it's like they're different. Or even when it stops running, then all of a sudden there's no movement, so you can have that kind of notification system as well. But the last thing that I want to show you is something that, as again, I work at Stripe, so even though I looked into this technology not thinking about Stripe at all, then I started asking myself the question, well, okay, if I could use that for payments, what it would look like. And I started thinking about gesture-based payments. And an interesting thing is that I realized doing research that there's already patents for that. I was just like, oh my God, like other people, I thought it was a bit like, no, nobody's going to do that. But no, there's actually multiple patents already filed around thinking about gestures for payments. And the one that's here is about having a gesture control module on the credit card that would kind of authenticate the payment. So you would still need, the credit card and payment is like heavily regulated. So, there's still, you couldn't just do a movement and pay. You would have some kind of authorization, or you need the credit card data to be sent a certain way. So you have the normal chip, to have like tap to pay or something, but then you could authenticate a payment using a custom gesture that a user would have trained through a system. So I tried to kind of prototype something similar, and so this has no sound. But I used a Stripe physical terminal, and I created like a fake UI that sells a book. And I tap my fake Stripe card, and it's going to ask me to do a gesture. And the first one is incorrect, so it doesn't process the payment. And my second gesture is the one that I trained, and all of a sudden the payment is processed. So that's like, again, a prototype of just exploring ways that this could work. And yeah, so definitely it's not available. Stripe is definitely not, releasing this. But it's just a way of thinking like, oh, I would have never thought that this was a thing. And then doing more research, I realized that there's actually applications for it. So as I'm getting to the end of my talk, but as like a final recap, you can do machine learning in JavaScript using TensorFlow.js. I showed you an example of it, but there's actually a lot more you can do. If you're interested more in object detection, there's open source models for that. If you're interested in sound recognition, there's cool models for that as well. The Web Bluetooth API, if you've never played with it, like I love it. I showed you, with this Arduino, but any Bluetooth device that you have, if it's Bluetooth low energy, you can actually get data from it in the browser and build whatever you want with it. And then finally, this type of example is IoT on the Jamstack. So there's no server, it's all front-end code. There's not even like an AWS, like a function, like a Lambda function or anything. It's really JavaScript code with web APIs that are already available. Let's not talk about browser compatibility, because I think it's just Chrome. But if we don't think about that, then you can do all of these things. Like, it's really accessible for front-end devs, but only it means that you can explore with technology that you might not really know about, but in only maybe like not even a weekend. You don't have to sacrifice your entire time to learn something that is not part of your job. But anyway, I'm done with this talk, but hopefully you learned something, and I personally believe that my role as a technologist is to explore tech, even though I might not work with it day to day. You never know when you're going to need some type of knowledge. I'm really interested in what's possible. So obviously, I don't think that you're going to go back to work and buy a bunch of Arduinos. But hopefully, you realize that, oh my God, that's possible, or you have ideas that are completely unrelated. But yeah, anyway, so if you have any question, I'll be around. But otherwise, I'm at DevCharlie on Twitter. But thank you so much for being with me this morning.
Thank you very much, Charlie. So we have a few minutes if you want, and if you have any question, we are going to give you the opportunity to ask them.
Hello.
Hello.
Thank you very much for the presentation. That was awesome. I have only one question. I cannot think about at the top of my head about a usage of these technologies. It's always about an app that you install on your watch and stuff. So do you have any example of a usage of something like that on the web? If it is Jamstack, it's
So, I didn't think about that. So there's the first thing that comes to mind so on the web. Because the thing is, now on the web, you can build a progressive web app. So you would have it on your phone as an app, but it would be built with web technologies. And the only thing I remember is a few years ago, a friend of mine had an app where to unlock your phone, you would to unlock your laptop, you would knock on your phone, and it would sense the vibration and unlock it. But that's probably not really related to that. But what I wanted to do is actually use an Apple Watch like that and try. I don't have an Apple Watch or an Android watch like any smartwatch, but I wanted to kind of create a system like that, but on the watch so that I wouldn't have to have an external device. And I wanted to do that with JavaScript, but again, I'm not sure it's possible because I don't know if you can have a progressive web app on an Apple Watch. I don't know. If somebody has an Apple Watch, you can tell me.
Apple doesn't want to.
Yeah? Yeah, okay, right. Well, then, an Android watch, then. I think Google just released something. But at the moment, I have not seen one, but I would love, you can build it if you want. It's good.
Thank you very much.
Thank you.
All right, yes.
Hi, thank you for this great talk. I have a question about the model you built and then you transfer to the card. What is actually the language or the reality of this model? In which language it is coded? And what is the constraint on the board to be able to run actually the model live?
So, I mean, with TensorFlow, if you only use TensorFlow and not TensorFlow.js, you have it in JavaScript. But the thing is, you can also sometimes convert a model to be used in different languages as well. So, for example, in JavaScript, I'm using a model like that's, I created my own model in JavaScript, but you have different scripts that can convert a model from one that's used from Python to JavaScript. So for production things, I probably wouldn't use JavaScript. I would rely on Python. But if you wanted to, I don't have that much experience with more native mobile applications, so I wouldn't know. But I would assume that you can maybe use something else than TensorFlow. I mean, I use TensorFlow because that's what I started with, but there's probably people who build libraries that allow you to do that type of stuff with different languages as well. I'm sorry that wasn't like a straight answer because I haven't played with it.
So it means that actually the Arduino has a JavaScript engine on it.
The Arduino?
Yeah.
No, it's running everything in C. So there's a script. So in the script the sketch that you upload to the Arduino, there are certain files that are that I didn't dive into that implement the ability to run the model. So it's not creating it, but it's running it. And I don't have the details for this now, but it's all in C on the board.
Okay, thank you.
No worries.
Thank you very much. We have time for one last question, if anyone has one. Well, in case I have one, you have presented us a whole stack of technology, opportunities, and does it brings upgrades to some other means that we can use today, or is it filling a void in the landscape of technical opportunities?
Well, for the JavaScript one specifically, to me, it feels like it fills a void in the sense that it opens that door to a lot more people. So when I started looking into it, I used something called scikit-run because I was doing it in Python. And when I realized that all of this was possible in JavaScript, I moved on. I moved on to using that because that's the language that I already know. So it means that if you add up learning Python plus learning machine learning, that would be like a lot of my free time. And every time I can kind of like stream it down to something that would use less of my personal time, I would do that. So for me, it fills a void, but also I feel like I would like for somebody to build a production thing in JavaScript, in machine learning. So to me, it's not my job, so I can't really focus on that. I see a lot of people building examples, but I would love to see something that's a real product. I know that, especially in the machine learning field, a lot of people are talking about, oh, Python is the real deal. But the fact that you can train this whole machine learning in the browser in a few seconds through a UI is like it opens the door to so many more people. So I know that maybe JavaScript is seen as a joke in that space, but I don't really believe so. I feel like there's a lot of improvements that are being made, and it's supported by Google, so they have engineers working on this full time. So I see it more as like filling a void in terms of improvements to the whole space. I think at the moment, maybe the fact that it's more like user-friendly, but otherwise in terms of functionality, it does the same thing as other languages from what I know. Yeah.
Thank you very much, Charlie. Give it up for this great talk.